Right, hello everybody. My name is Jerome. I'm based in the UK. Managed a company called Hexagon Data Services. I've been going for nearly 4 years now, and we offer a range of data services to varied clients, from the education sector to pharmaceuticals. So we work with a lot of data sets, a lot of different data sets, providing data warehousing solutions, data engineering solutions, and also looking after people's visualization through Power BI primarily. That's our key tool. Before I go into the demonstration, I just wanted to presentation. I wanted to give you to just say many thanks for joining the session today. It does mean a lot to us, especially if you come and listen to me for half an hour, 40 minutes. Taking that time out of your busy schedule is much appreciated, and also a big well done to you for, I guess, investing time in your own learning journey. And I do hope you will find this session useful. So I've got a couple of slides I'm going to go through with you. And today we're going to talk about Microsoft Azure specifically for data engineering. And often when I speak to clients or prospective clients, they don't necessarily know much about Azure. They know it exists, they know it's a Microsoft product, they understand it is cloud-based, but they don't really understand the capabilities Azure as a platform can give them, and how it can support their businesses on a day-to-day basis. So we often have a brief chat about what actually Azure means for them. And I personally, because Azure is such a large platform, it offers over 200 cloud-based services and products which are natively available through the portal, and because it is such a big platform, I tend to break it down into two main component parts. One is geared towards IT teams, and one is geared toward data teams. So what I mean by IT teams is the ability for companies to use the cloud to run their IT infrastructure, have cloud-based servers running on virtual servers, put their storage in Azure in the cloud again, and really save a significant amount of money on the overheads that are associated with running your own IT infrastructure and having to manage your own servers, network routers, cabling, and all that. And also, there is always a big emphasis on security. And if you use Microsoft's Azure cloud, then you get all the security benefits of those Azure services, because Microsoft will look after the data center from a physical point of view, also from a more of a software perspective, looking after updates, making sure that the systems are patched and that security features are applied wherever applicable. So that's the IT side of Azure in the way I explain this to clients. And then there's a whole load of services that are more relevant to data teams, so teams of data analysts or data engineers or even data scientists. And Azure is really a fantastic platform if you work in data, because you get access to tons of resources that you wouldn't have been able to access very easily in the past. So just going to go over a couple of examples briefly, and then we'll go through a bit more detail on some of these. But for example, Azure allows you to create storage accounts and SQL Server databases. So a storage account is a place where you can save files, so normally semi-structured or unstructured files, CSV documents, Excel files that you want to process. Maybe images if you work with machine learning processes that require image processing. So you can take full advantage of Azure's storage accounts or blob accounts, or sometimes called data lakes as well. So these are all the same type of accounts. The key benefit to those storage accounts is that they are really quick to set up and have up and running. They relatively cheap, and they're certainly much easier to maintain and to access than FTP servers would have been in the past. So typically, before those cloud platforms existed, if you wanted to share files, large files on a relatively big scale, you had to install an FTP server, open it up to the internet, and people would access files that way. Now with storage accounts, you can have a similar set of capabilities up and running within seconds. The other advantage of storage accounts in Azure is the ability to connect to those storage accounts using a wide range of SDKs like Python, for example. I'll come back to Azure SQL Server in one of the next slides. And then you've got also a wide range of data warehousing tools or tools that can help you set up your data warehousing and data analytics platform, such as Data Factory, Synapse, or Power BI Embedded. Again, I will cover Azure Data Factory in more detail shortly. As I said earlier in my presentation, Azure can be a great platform for people who are interested in AI and machine learning. And there's several tiers in terms of development requirements, if you like. The most accessible tier is called Cognitive Services, and that really allows you to plug your own systems and procedures into some out-of-the-box AI features that are available with very low code requirements on the Azure platform. And those cognitive services allow you to do things like sentiment analysis, key phrase extractions. You can also analyze images. I have recently also discovered that Azure have released a language studio, which is fairly new, and that language studio allows you to use some of the features, capabilities within cognitive services, but actually create more bespoke solutions. So you can label your own text, and you can, building on the cognitive services, completely tailor your machine learning models to your specific needs. Again, this requires very low coding knowledge, and it is very efficient and quick to run. So if you have a use case that you might think would require a machine learning model, then rather than spending a lot of time building all the algorithms and the infrastructure, you should consider taking a look at the language studio within Azure, and maybe give that a try initially, and if it meets your requirements, then that's perfect. As I said, if you're more into machine learning, you want to write your own machine learning algorithms, and you want to use specific types of algorithms or specific libraries like TensorFlow, other libraries available through Python, then you can run your own machine learning models. You can build them, train them, deploy them on Azure using the Machine Learning Studio. I'm not going to cover the AI parts in more details in this session. It's just a quick introduction, just to make you aware that these services exist. And finally, before I look into SQL Server in more detail, I just wanted to make you aware of other tools for automation within Azure Data Factory, which can really benefit data teams. And one of those tools is called Logic Apps. And Logic Apps is the Azure, or the server, if you like, version of Power Automate, which is a tool most of you would probably have heard of. The advantage of Logic Apps is that it resides within the Azure portal, so you can very easily connect to your Azure resources through Logic Apps. And the costing model is also quite advantageous. If you run Logic App tasks within Azure, you effectively have a range of options. One of which is to use a consumption plan, which effectively means that you only pay every time a process runs in Logic Apps, and the cost of those Logic App processes is quite reasonable. So if you want to automate tasks such as updating database records based on certain triggers, or sending emails or SMS messages to contact lists at a specific point in time, and all these are the type of tasks that you can run through Logic Apps. There's many connectors available, and that list of connectors is growing all the time. So again, if you are in need of some automation within your team, if you've got processes that require automation from a data point of view, then you should really take a look at Logic Apps. So in today's session, obviously we've already covered a lot of the available Azure resources, but I didn't want to spend more time talking about SQL Server, going back to storage accounts, and then introducing you to Azure Data Factory in more detail. I have kept something from the slides that I would also like to discuss with you towards the end of the session. This is something I've been working on pretty recently, which I think is going to be also quite valuable to you. So first of all, let's have a look at the Azure portal. So if you're new to Azure, this may be slightly overwhelming. There's lots of components, lots of icons, but actually once you start using the Azure portal, you will appreciate how consistent the interface looks and how well it all integrates. I've used other web-based, cloud-based platforms that are not as user-friendly as Azure. I find that Azure is pretty well structured for such a large platform. When you create a new Azure subscription, you have the ability within that subscription to then create resource groups. So if you work on specific projects and want to keep your resources, such as your storage accounts or SQL Server databases or any other types of resources, if you want to keep those resources together for logical reasons, so you can find them more easily, or for costing purposes, so you can monitor costs more granularly, then using those resource groups efficiently is going to make a big difference to you, because what that means is that In practice, once you've created your resource group and added all the components you need within that resource group, you will always be able to find what you're looking for fairly easily through the portal. If you only had one massive resource group for all your projects, then you would be you would probably get lost in the list of services very, very quickly. So definitely recommend using resource groups effectively. Think about how you want to structure your project. Maybe think about a consistent naming convention as well. If you run large scale operations, it makes sense to have a fairly clear naming convention for your resources. When you deploy a resource in Azure, most resources are attached to regions, so you can choose where you want that resource to reside and which data center you want it to, maybe not down to the data center, but at least to the region where you want that resource to actually be stored. And that really allows you to go around data protection issues if your company or your clients have got specific requirements around those areas. Each region can have slightly different costing models, so you just need to be aware when you create a resource that you need to check the price of that resource in the region you deploy it in. But generally speaking, the Azure portal is also very good at telling you before you actually create a resource what the likely cost of that resource will be. So if you create an SQL Server database before you get to the final step in that process, you will have an understanding through the creation process of how much that specific resource will cost. So this is the resource groups and why they're important. Moving on to SQL Server. So if you work in data, there's often scenarios where you need to deploy databases, so either for staging tables, so if you want to store data before it's being processed, or if you then want to build data warehouses that don't require systems like Synapse or other more expensive platforms, you can use SQL Server to build medium scale data warehouses. It's a platform that is commonly used for this, and the advantage or the advantages of using SQL Server in Azure are that you can have an SQL Server up and running within a few minutes. The process of creating a SQL Server in Azure is very straightforward. So you go to your Azure portal, you go in your resource group, you search for the SQL Server resource by clicking the Create Resource button on the interface, and you just need to enter a couple of straightforward parameters, and the SQL Server will then be available to you within, as I said, within minutes. Once the SQL Server itself is available, you can add to that server as many databases as you require. Again, the process of adding a database to a server is pretty straightforward. The console itself will then give you access to lots of metrics, so you can monitor the performance of your database through the Azure portal. You don't need to run any scripts to get the data out of the system. Most of the information you will need is available straight out of the console. Obviously, like any on-premise SQL Server database, you can use SQL Server Management Studio to log on to your databases and have a more familiar experience if you're used to using SQL Server Management Studio on your desktop. This will also give you added capabilities, obviously, that you don't get through the portal. You can also, if you prefer, use the Azure Data Studio, which is another desktop tool that allows you to connect to databases. I tend to use Management Studio because it's a tool I'm used to, and it works well, even though it looks a bit out of date. The other benefit of running SQL Server databases on Azure is that you can very easily manage the amount of resources you need to run those databases. So again, through the Azure portal, once you're connected to the database, you can just click a few buttons and change the compute and storage capabilities of your database. So Azure has multiple pricing options, a standard model which allows you to select the number of vCores that you want to assign to your database, or a slightly more abstract model based on what Azure now calls DTUs, which stands for data transaction units. So you just set the DTUs that you require against your database from 10 to several thousands, as you move the slider to increase the resources on the database, you will see immediately what the cost implications of increasing the DTU resources on your database are going to be. It is very much a case of trial and error. You can start, when you build a new database, you can start on a fairly low DTU setting. If you require large amounts of storage space, then you will have to go above a certain threshold, but it's normally quite generous. So storage is not normally an issue when it comes to using SQL Server. Then you will quickly see when you start using your database in production environments, you will quickly see through the console whether the performance of the database is good enough, and if it isn't, then you have the ability to increase those DTUs. If you can predict when your database will get accessed most, then you also have the ability to use Logic App, which is the automation tool I mentioned earlier. You can use Logic App to set, increase or decrease your DTUs at certain points in time. So if your database is mainly used during the day, then what you can do is say from 7 a.m. I want to increase my DTUs to X, and by 8 p.m. Reduce those DTUs to the minimum available tier based on your database storage, and that means that obviously the database won't perform well overnight, but if very few people or nobody accesses it, then that might be okay. But you will then get some significant cost savings by doing this. So in a nutshell, that was some of the reasons why you might consider using Azure to deploy your next SQL Server databases. We briefly talked about storage accounts or data lakes at the start of the session. So storage accounts are really great at keeping unstructured or semi-structured data in a central location. They're particularly good when it comes to then being able to access the data through other tools and platforms, so you can easily share share data using storage accounts with other systems. When you create a storage account, you have the ability to completely manage the security aspect around that storage account. So you could lock it if you wanted to. So it would only be available to other resources within your Azure subscription or within an Azure resource group. So if you didn't want anybody else to be able to access that storage account, this is something you can manage from a security point of view through the Azure portal. However, if you have data that can be shared with other systems or other users, you can slightly relax the security aspect from a networking point of view, but still have fairly strong access keys which act as passwords that then allow you to connect to your storage account. So it really depends on the type of data you store and the privacy and security aspects around those data files. But there is a lot of flexibility within the platform to manage the security of your data at a very granular level. I mentioned before that one of the advantages of storage accounts is that you can connect to them very easily using systems like Azure Data Factory or SDKs such as Python. I believe you can use Ruby or Java programming languages to access storage accounts and build within your systems or applications access to those storage accounts natively. When you build a storage account, you have the ability to create what is called a container, and that container will then host the files you upload to the portal. You can create many containers on the same storage account. You can also choose to create a data lake. The terminology is slightly different on the portal, which is effectively a storage account which gives you the ability to create a hierarchical structure, so be able to add folders to your containers in essence. Okay, so the final element of Azure I wanted to briefly introduce today is called Azure Data Factory. Data Factory has been going for a few years now, and it has its own studio. So when you're in the Azure portal and open up Data Factory will open in the new interface, but it is fully web-based. You don't need to run any software on your machine. You don't need to download any desktop applications. It is completely web-based. Data Factory is evolving rapidly. Microsoft are clearly seeing this product as one of their flagship data solutions, so they're investing large sums of money to make it better on an almost daily basis. So Data Factory is a cloud version, in my mind anyway, of the previous SQL Server Integration Services tool, or SSIS, which was part of the SQL Server stack with analysis services. But it comes with many added benefits. So with Data Factory being a cloud-based solution, you don't need to worry about managing the infrastructure behind it. You don't need to run your own server. All you do is deploy a Data Factory resource in your Azure subscription, and that will then give you access to this Azure portal. You can hook Data Factory up to GitHub as well for version control, so you can fully manage that development lifecycle through the portal itself. And what Data Factory allows you to do essentially is build data pipelines, and like Logic App, you get a wide range of connectors, so you can connect to SQL Server databases, you can connect to Snowflake, you can connect to your storage accounts in Azure. Most of the AWS data resources like Redshift or S3 storage are also compatible with Data Factory, so it really opens up a lot of possibilities and allows you to connect many different data sources very easily within the same platform. Once you set up a Data Factory, you can then create those linked services, those connections to other platforms very easily. Once you've got those connections up and running, you can then build pipelines which allow you to effectively build a chain of commands that allow you to take source data, transform it, so you can create derived columns, you can join multiple data sources together, you can select certain fields or filter values out of your data sources. You can also pivot data. There's loads of functionalities within those pipelines through what is called data flows. So what you see on the screen here is a data flow that takes multiple sources, which are here on the left-hand side, applies a range of data transformation, in this case to build a slowly changing dimension of time to slowly changing dimension for a data warehouse. And although you can't see it on the right hand side here, you've got then the data sinks. You can see one there, which is the destination of your data. So this is a perfect tool for building data warehouses in Azure. It really has most of the capabilities you need. Within Data Factory, you can build loops, and you can also connect to APIs. The data flows you see here will also take variables and parameters, which sometimes can be very helpful if you want to avoid duplicating efforts. So if you've got a generic pipeline that can apply to different data sources and destinations, then you can pass table names as parameters, so you can run the same data flow, the same pipeline on a range of different tables without having to rewrite the same pipeline multiple times. So it is very good at utilizing those parameters and variables. Data flows are probably the most powerful components of Azure Data Factory, and they can be linked together in a pipeline. So a pipeline is just a set of commands that you run in a sequence. Data flows can be part of a pipeline. So when you trigger an Azure Data Factory task, you trigger a pipeline, but that pipeline can contain other pipelines, or it can contain data flows. There is a relatively new feature in Azure Data Factory which allows you to run Power Query scripts on Azure. So if you're familiar with Power BI or Power Query in Excel, you will know that Power Query is extremely easy to use, that it allows you to run your data in a very quick and easy way, and often the limitation with Power Query, if you use it in Power BI or Excel, is that it is restricted to you locally in a way. So if you want to take advantage of running Power Query scripts in a more server-based environment, then Azure Data Factory could be the right tool for you. So this kind of concludes my session on Data Factory and the Azure portal. So the one last thing I wanted to bring up, which I haven't included in my slide, is something, as I said, that I've started using quite recently, which is called Azure Functions, and these are serverless functions that you can build within Azure. They're normally geared towards web applications, but I have found them to be quite useful for running Python code on data processes. If you want to extract data, process it in data frames, and run Azure scripts, Python scripts within your data flows, data processes, and utilizing Azure functions that can be built into Azure Data Factory as well is another great option that is available through Azure. So we've covered a lot of ground. I hope you have found the session useful. So I've been Jerome Wittersheim. You can find me on LinkedIn. If you have any questions, please reach out. I will also accept your connection requests. I strongly believe in the power of networking. So yes, feel free to get in touch if you want me to answer any of your queries following today's session. Thanks for your time.